Finally, after lots of trying, I managed to get my robotic arm project started. So this project is originally for 6 degree of freedom robotic arm development, but this is the prototype consists of only 3 degree of freedom robotic arm. It consists of 3D printed robotic arm part and 3 of the servo motors. This is controlled by Raspberry Pi 4 single board computer with Adafruit 16 channel servo controller, and I have mounted it on the Arduino buggy, or otherwise called the TT motor buggy. So this is my Raspberry Pi 4 single board computer, and as you can see, this is 16 channel Adafruit servo controller. It was quite challenging to get all the part printed, then with the weight ratio to fit them properly. But in this video, I will try to be as much explanatory as I can. Now let's get started. As you can see, this part, the arm itself, is from a different project, and it has got one of the servo motor controlling the grabber arm, and it has got 3 pin. This 3 pin is connected with the servo controller, and the last servo is mounted at the base plate. Now let's assemble. At the moment, as it is in basic prototyping stage, so there is it's not a finished product, so still there is some trial and error going on with this project. So this is the metal mount I'm connecting with the servo, and the robotic arm, this one does not have any metal mount. It has got this plastic mount. In this way, now I will connect to the 16 channel servo controller. Connecting the Raspberry Pi 4 with Adafruit 16 channel servo controller is relatively easy. There are 2 pins need to be taken care of: the VCC, ground, SGA and SCL. I said 2 pin. This SGA and SCL is the most important one, and VCC and ground, everyone knows where they goes. VCC goes to the 5-volt power supply, and the ground goes to the Raspberry Pi 4 ground, any of the ground. But the SGA goes to pin number 3, and SCL, the serial clock pin, goes to pin number 5. Now my 3 servo is connected. The first one, this servo, is connected with the pin number 0. Then the next one is connected with pin number 4, and the other one is pin number 7. So pin number 7 is this servo, pin number 4 is this servo, then pin number 0 is this servo. Now I have connected my laptop with the Raspberry Pi 4 via the real VNC. I do use Spider 3 IDE. This is the code I'm using for basic demonstration of robotic arm movement. So from the beginning, as you can see, I have important time. Then I'm using the Adafruit servo kit library. From Adafruit, import servo kit. From time, import sleep. Then kit. I have used it as a class. So kit equals servo kit channel 8. Then I'm using a while loop. Inside the loop, so there are 3 pin I utilized. Pin number 0, 4, and 7. If you recall it, pin number 0, 4, and 7. So the first pin is a 0, 4, and 7. So 7 would be this pin. So for the test purpose, I'm using the Spider 3 console. If I just paste this code from Adafruit servo kit import, so that has been initialized. Now here you can see this line of code. If I just copy it, then you can see the movement of, apologize, I have to initialize the pin as well. So after that, let's move pin number 0, the base plate servo. If I do that, hopefully you will see some movement. So that's almost was going to break my robot arm, but that is happening because during the prototyping stage things are not perfect, but this way at least I can initialize the pin number 0. So whatever the location of the servo at the moment, it's in pin number 0. Now pin number 4, the second servo, I'm initializing it to 0 as well. We'll be able to see what is going on there. So it has been initialized on the 0 location. I just took off the arm and reconfigure it to its 0 location. So at the moment this servo is in 0 location and this servo is in 0 location as well, and this is I did not change anything, so this is by default in not exact 0, it's in 0 location. Just to confirm, pin number 7 of the servo, the this board is in 0 location, initialized. As you can see, the arm is a little bit open, so that is by default in 0 location. I can change the hardware configuration later on. So this way, basically, the hardware setup has been completed. That means that all the physical position are in 0 location, the default beginner location. Now, if I now play my code, let's run the code and see what happens. Oh, it's broken. It's all broken apart because the physical position is not what I thought, but never to worry, because it's really easy to just put it back. Nothing has been fastened too hastily that to prevent it breaking. Now the robotic arm, all the motors, servo motors, has been initialized at 0 location. So basically I put the code on, so the code initialized the servos in 0 location. Then I physically put in different location. For instance, if I can just take it off and I can put this way or I can put this way, but I put this way for the best configuration at the moment for the show and tell purpose. Now I'm again using the console. Console is really handy for prototyping purpose, especially in this Spider 3 IDE, which has got many similarities with MATLAB. So if I just move the servo in, try to look carefully, in 10 degrees because I don't want to break it again. So let's see what happens. So I'm pressing the button, enter button, and it will execute the servo number 4, which is this servo at 10 degrees. Let's see what happens. Servo number 4 in 30 degrees. Let's see what happens. So as you can see, servo number 4 has been moving anti-clockwise 30 degrees, 60 degrees, 150 degrees. At last 170 degrees. So at the moment this servo is 170 degrees. I'm just setting this location because this code will execute this location, and I want to make sure that they are safe for the movement, they are not colliding with any other part. Now I'm not really sure if the robotic arm is ready for this code to be deployed, but I got nothing to worry about because there is no way it can be totally destroyed because this is really flexible. Now if I play the code, let's see what happens. So as you can see, this has fall apart, but nothing to worry about. I will put it back, but before I put it back, I make sure all the servo positions are in 0 location. After setting it up, Let's play the code again. Again broken. So I need to say tune the code again. Let's run the code this time. It's still a bit rough movement, but that can be taken care of once I'm satisfied. Here you go, broken again. So at the moment I can conclude that the basic robotic arm itself is working, but there are much of work need to be done, and now I will leave it at this stage, and at the next video we will fine tune the robotic arm and we'll enhance the code as well. I'll see you at next time. Here you go.